We already learned what is voltage and what is current. Those who are not watched our previous tutorials, please watch them before you continue. Everyone must have noticed all electronic appliances mentioned its voltage values on it, like 12 volt, 24 volt, 110 volt, 220 volt, etc. And we know this is the maximum voltage that can be connected to that particular device. If you closely observe, you can see two different symbols along with voltage value. Either a symbol which resembles sine wave or a symbol made of dashed lines and solid line. And in some cases, in place of these symbols, there might have written VDC or VAC. What does it mean and how these symbols are important in electronics? Let us see. From our previous tutorials, you must have understood the fundamentals of electronics, that every circuit or device performs its job only when there is an electrons flow. And in order to create electrons flow, in every circuit or device, there must have a pushing force called voltage source. In our previous circuits, we used battery as a voltage source because battery is a very simple, easy and safe voltage source that any beginners can handle. But battery is only one among various types of voltage sources available today. Hence, the behavior or the flow of electrons in the circuit may vary, depends on what voltage source is used and how it works. We know the flow of electrons, generally known as current. Based on the direction of electrons flow, the electric current is classified into two types: direct current and alternating current. So, direct current means electrons always flow only in one direction. As water comes out of water pipe, it always flows from pipe to ground, and there is no water flowing back to pipe. Means here water flowing only in one direction. Similarly, what we have seen in our previous lamp circuit is direct current flow because battery creates electrons flow in same direction throughout the time. As battery generates constant electrons flow in same direction, its voltage also remains constant. Means if you check voltage of a 1.5 volt battery or any other DC source with a multimeter, always you will get 1.5 volt reading. Hence, if you plot its voltage value on a graph with respect to time, you will get a straight line. So, in all equipments which runs with direct current, its voltage value mentioned along with a symbol that made of solid and dashed lines. Or, in some cases, in place of symbol, there may have written VDC, volt of direct current. Both symbols indicates that these devices will work only with DC voltage source. Another type of electric current is alternating current. As its name indicates, it is an alternating or changing current. Suppose in a DC circuit, what will happen if polarity of battery has changed? The voltage value becomes negative and thereby electrons flow will be reversed. You can observe the same with a multimeter. When battery polarity changed, current value shows negative, means the current is flowing in opposite direction. It is similar to this water analogy. Here, the wheel is rotating in clockwise and anti-clockwise direction as water flow direction changes. Suppose, if we change polarity of battery frequently, the flow of electrons will change its direction forward and reverse with respect to battery polarity. And simultaneously, its voltage also changes between positive and negative value. This is also an example of changing or alternating current. But in most conventional electricity generators, they generate electrons flow in alternate direction over the time. Or the current keeps switching its direction periodically forward and backward. But the changes happens gradually from positive to negative and negative to positive. As flow of electrons gradually changes its direction, its voltage also changes simultaneously. Hence, the voltage variation looks like a sinusoidal waveform. We know in house and offices, most of the electrical appliances are powering by connecting it into the sockets, where electricity is available ready to use. This is the most commonly used electricity source and it is actually delivered in the form of alternating current. That means here also current flows in forward and reverse direction periodically over the time. Hence, voltage keeps varying between positive voltage and negative voltage periodically. For example, If you light up a bulb using AC voltage supply, it is not actually continuously glowing. Its brightness keeps varying according to voltage variation, but it is not visible to our eyes. And even difficult to understand this voltage variation with a normal voltmeter or multimeter, because here the variation happens very fast, approximately 50 or 60 cycles passing per second. One complete cycle includes one positive half cycle and one negative half cycle. Such 50 or 60 complete cycles passing per second in an AC voltage supply that reaches our home or office. It is called frequency of AC voltage and it is measured in the unit of Hertz. In all equipments that runs with AC voltage, it indicates the same by a symbol of sine wave or might have written VAC, volt of alternating current. And the manufacturer must have mentioned its frequency also along with voltage value. The behavior of AC current and its frequency can be measured with advanced multimeters or instruments called oscilloscope. The AC electricity reaches our home and office are regulated by respective countries. In India, the AC voltage is regulated between 220 volt and 240 volt AC with 50 cycles per second. This is similar to most countries in the world, including Australia, Europe, and UK. But it is fixed at 110 volt to 120 volt AC with 60 cycles per second in US for small appliances. Why batteries provides direct current and electricity we get from power stations are in the form of alternating current? That is purely depend on how they are generated. In battery, the electricity is generated purely by chemical reaction between materials inside the battery. As chemical reaction inside the battery is a steady process, its output remains constant throughout its lifetime. But the electricity we get from electrical outlets available at home and office are coming from power plants, which traveled all the way from power plants to our home or office through conducting cables. In power plants, the electricity is generated by electromechanical electricity generators, where mechanical energy is converted into electrical energy in the form of alternating current. Hence, they are known as AC generators. These AC generators also known as alternators. Wind electricity plants, tidal electricity plants are some examples where electricity is generated with help of AC generators. AC usually prefer to transmit over long distance because of its various properties among DC. But AC and DC has its own advantages and disadvantages and they have specific areas of use. Even at house, we know mixer grinder, oven, refrigerator, washing machine, fan, television all are running with AC supply. Meanwhile, torchlight, wall clocks, remote controller, laptop, mobile phone all are running with batteries or DC source. Some devices may require both AC and DC, like washing machine. In that, the motor runs only with AC voltage, but its circuit boards require DC voltage to operate. In such case, it is necessary to convert AC to DC. There we use AC to DC converter circuits called rectifiers. The circuit inside mobile chargers, laptop adapters are actually converting AC to DC. In some cases, DC needs to be converted to AC, which also possible with DC to AC converters called inverters. That's what doing in our home inverter system, where the electricity stored in battery is converting to AC to run home appliances. This video just intended to make basic understanding about AC and DC. We have much more to learn about AC and DC, how they are generated, what is happening in AC and DC generators, its advantages and disadvantages, all that we will learn in upcoming tutorials.